Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. Uh-oh, we're being observed by Mr. Sanders today. Please be on your best behavior during this lesson. Lesson 6, segments that meet at right angles. Classwork opening exercise. Carlos thinks that the segment having endpoints A00 and B60 is perpendicular to the segment with endpoints A00 and C-20. Do you agree? Why or why not? Well, keep in mind that in order to determine if two segments that have shared endpoint at the origin, all we need to do is multiply our x values. So we take 6 times -2, and we add that to the y values product, which is 0 times 0. And those have to equal 0. So do the products of the x's plus the products of the y's equal 0 in this case? Well, 6 times -2 is -12. And obviously 0 times 0 is 0. So -12 plus 0 does not equal 0. So therefore, I do not agree. And this is why. Okay, working with a partner, given the point A00, B3, -2. So we have a segment AB that goes to the origin. Find the coordinates of a point C so that AC is perpendicular to AB. Okay, so AB is here. We need to find a segment endpoint of C so that AB is perpendicular to AC. In order to do that, we have to have the products equal. So here's what we're going to do. We already have the point B, which is 3, -2. We need a point C that has some X and some Y value. So let's just use that formula from the prior lesson and multiply our X's and multiply our Y's. So we need 3X plus a -2 times Y to equal 0. Okay, so if I solve for Y, I have to subtract 3X from both sides. This is a 3, by the way. And 3x minus 3x cancels, and I'm left with -2y equals a -3x. To get y by itself, I divide by -2 on both sides, and therefore I get the equation y equals a negative divided by a negative is positive, and I get y equals 3/2 x. Okay, so now I can choose points. So now I know that I can take a C and choose any X value. I prefer to choose even since my denominator is 2 and they'll cancel. So how about I use 2? So if I choose the point 2 for my X value and substitute it into here, then it will give me a dependent. Y will depend on what X is, and Y will have to satisfy our product rule. So if I take that 2 and substitute it in here, I will get Y equals 3/2 times 2, or 2/1, and the 2's cancel, and I get y equals 3. So I have the point 2, 3. So if I check that, 3 times 2 is 6, -2 times 3 is -6, 6 plus -6 does in fact add up to 0. Let's pick another number, a bigger one. How about 8? So if I said y equals 3/2 times my x, and now my x is 8, then I'd have this. So this would give me the point C with an x value of 8, and these will cancel out to be 4, and 4 times 3 is 12. So that would give me y equals 12. So the point 8, 12 would also satisfy this. There are infinitely many solutions to this. It would be all the points on the line y equals 3/2 x. Okay, so now this example, it says that given points A22, so I'm going to graph these. I brought a graph in. Since this is our first attempt at this, we're given 4 points, none of them which share an endpoint of the origin. We have a point 22. We also have a point 1016. That is our segment AB. So here's B and here's A. So let me draw a segment, and let's make it blue and thin that goes from A to B like so. There's segment AB, 2, 2, 10, 16 endpoints. We're now going to do the same with the other point, which is, let's use purple, -3, which is here, 1, which is halfway between 1 and 2. So there's -3, 1. And 4, -3 would be here, halfway between 2 and 4, -3. So there is the other segment. And let's do this one green. Choose the segment, choose green, and choose thin. And I'm going to draw a segment. So there are our 2 segments. All right. So neither one of those are going through the origin. And if this continues down, we're going to miss the origin. So these don't go through the origin. So what do we do? Bernie, do you have any solutions? All right, so here's what I think we should do. I think we should translate AB from the point 2, 2 over to 0, 0. So remember way back in module 1, we had what's called a vector. So what's the vector, Victor? Or in this case, what's the vector, Bernie? Okay, so if I want to move the point A to the origin like so, there's my orange vector. Well, a vector is drawn like so. Instead of using parentheses, we use, it looks like a less than symbol and a greater than symbol. It's just a V bracket, if you will. And we're moving the X value left 2 and the Y value down 2. So it'd be the -2, -2 would be our vector translation. So that would move A to 0, 0. And then if I move this, actually, I don't want to move it. I want to copy it. Just showing you the visual of this. And then if I put this at B, that will show us where to put our endpoint B. So if we're going to move it down 2 over 2, left 2 down 2, we're going to end up at the point 8, 14. So I'm going to move this now down to the origin like so. And notice it ended up at our endpoints of our vector. And now we have that same line segment that was shifted over and down. So it has the same slope. And so now it's going from the point A, 0, 0, and the point B is now 8, 14. Okay, now we're going to do the same with this green line. So let me do another vector. And this one I'll make purple. So this vector's got to start there and go to here like so. All right, so I'm going to copy that. And I'm going to paste it down here. That shows us where the endpoints are going to end up. So I need to move this up just a little bit. Okay, like so. All right, so what did that do? It went down 1, right 3. So this is the vector -1, 3. This is moving that whole segment down 1, right 3. So then when I do that, this is going to end up at the origin, like so. And the other green end is going to end up at the point, well, let's label it. So now we have a point C, 0, 0, the origin, right? Here's C, and that's also A now, because C used to be here and D used to be here, 4, -3. I never labeled those. So here was C. So CD was here. We moved it over to here. So now here is D down here. And C has moved to here. And now these 2 points are at the origin. And the next question is, are these 2 lines perpendicular? So now where are we over here? We're at the point 7, -4. So D is now moved from here to 7, -4. And the other thing I want to point out to you is A was at 2, 2. And I subtracted 2 and subtracted 2. So obviously I got 0, 0. B was at 10, 16. 10 minus 2 is 8. 16 minus 2 is 4. Now we have the vector negative 1, 3. So that's just what we do to our vertices. So now if I'm looking at C, negative 3, negative 3. Did I do this right? No, it's not. Left, that's left 3 up. That's left 1 up 3. My apologies. Sorry, Bernie. Made a mistake there. And okay, so I'm glad I checked this. So X moved to the right 3. We were at negative 3, now we're at 0. To the right 3, down 1. My fault, I apologize there. And now I'm glad I did that because we're checking now. So negative 3 plus 3 is 0. And 4 plus 3 is 7. Check the y's. 1 minus 1 is 0. Negative 3 minus 1 is negative 4. Okay, so now we're working with B and D. Because A and C are at the origin, we can now say A, B is perpendicular to A, D if the x's plus the product of the x's plus the product of the y's equals 0. So if x, 8 times x, 7. So if 8 times 7 plus 14 times negative 4 equals 0. 7 times 8 is 56 plus, and it's a positive times a negative. So instead of saying plus and minus, I prefer to just write minus. 4 times 4 is 16. Carry the 1. 4 times 1 is 4 plus 1 is 5. And 56 minus 56 equals 0. 0 equals 0. Therefore, AB is in fact perpendicular to AD. Alrighty. How'd you like that one, Bernie? Okay, page 2 brings us to exercise 1. And it says, given a point A with coordinates A sub 1, A sub 2, point B, coordinates B sub 1, B sub 2, point C, coordinates C sub 1, C sub 2, and point D, coordinates D sub 1, D sub 2, find a general formula in terms of all of those sub 1, sub 2s that will let us determine whether A, B, and C, D are perpendicular. And what we're trying to do is find an equation that will work when line segments do not intersect at the origin. So in order to do this, let me go back to the last problem and point something out to you. If you move points like we did in this diagram here, like I moved this segment here, it was at the point 2, 2, comma, 10, 16. I moved it left 2, down 2 to get it to the origin. And that is what I did to my point A. So notice where A was, and notice our vector shift. So we are just subtracting the A values to get our segments to the origin. Okay. So if I did that with A, and then I move the other segment the distance away from C, notice our segment, our endpoint, and what we did as a vector translation, we did the opposite of C. So we subtracted C, minus a negative 3 is plus 3, and 1 minus 1. So we just choose 2 endpoints and we do a vector shift. So here's how we're going to do that here. So hopefully that's a little hint because this is an exercise. So I'd like you to pause the video here, see if you can figure out how to do this and come up with the equation. All right, so we're doing a translation. And so after a translation, we will get the point A prime to be at 0, 0. Okay, A prime is going to be at 0, 0. Well, where would B prime end up? Well, AB is a segment. So B prime is going to end up being my X value of B minus my X value of A. So if I go back here, what I did to A, I also did to B. I took 8 minus 2 and got 6. Wait, where am I? No, it was 10. I took 10 minus 2 and got 8. I took 16 minus 2 and got 14. So I'm going to do the same with my B1, B2. So it's going to end up being B sub 1 minus whatever A sub 1 was, okay, comma, B sub 2 minus A sub 2. So there's my new point B. I just subtracted what A was. And then if C is my endpoint and I get to the origin, now my C prime is going to be the point 0, 0. But what did I have to do? I had to subtract C1 from C1. So if C1 is 5, 5 minus 5 is 0. And if C2 was, say, -2, then I'd have to subtract a -2 or add 2 to get 0. And I have to do the same to D. So I'm going to subtract C1 and subtract C2 from D1 and D2, just like here. So my D prime is going to end up being D sub 1 minus C sub 1, comma, D sub 2 minus C sub 2. So there are our other two endpoints, and now A prime and C prime are the origin. And now I'm going to substitute these values in. Remember, we take the X value times the X value. So my new equation is going to be if A prime B prime is going to be perpendicular to C prime D prime, then we have to have the X value from the other endpoint. We have to have B sub 1 minus A sub 1 times D sub 1 minus C sub 1 plus, and then we're going to take our Y values, take the products of our Y values. So it's going to be B sub 2. This isn't minus, by the way. That is a times. And so let me fix that. This is times. It's the product, and then you add. Same with here. All right, let me just get this out of there. Oops. Okay, my fault. So it's B sub 1. Oh no, I was right before. Ay caramba, Control Z. All right. What am I thinking? Okay, so B sub 1 minus A sub 1 is my X sub 1, if you will. And D sub 1 minus C sub 1 is my X sub 2, if you will. So we're going to take X sub 1 times X sub 2. This is correct. My apologies. Plus B sub 2 minus A sub 2 times D sub 2 minus C sub 2. So there is our equation. Whew. And that has to equal 0. So let me fix that. Okay, so that's a little bit better. I lined it up here. So if A prime B prime is perpendicular to C prime D prime, then B sub 1 minus A sub 1 times D sub 1 minus C sub 1 plus B sub 2 minus A sub 2 times D sub 2 minus C sub 2 equals 0. So there it is in terms of A's and B's and C's and D's subs. All righty. All right, number 2, recall the opening exercise of lesson 4 in which a robot is traveling along a linear path given by the equation y equals 3x minus 600. The robot hears a ping from a homing beacon when it reaches the point F 400, 600 and turns to travel along a linear path given by the equation y minus 600 equals -1/3 times x minus 400. If the homing beacon lies on the x-axis, what is its exact location? Use your own graph paper to visualize this scenario. So let me do that first. Okay, so here's the graph paper. So let's just quickly plot these points. And we're at F 400, 600. So here's 400, And if I go up to 600, 400, 600 is right there. That is F. Okay, and so what are we saying here? A robot is traveling along a linear path given by the equation. The robot hears a ping from a homing beacon when it reaches point F. So this is the equation to get to here. So we're coming down from negative 600 and we have a slope of 3. So if I'm at 600, then I have to go down 3, left 1 to have a slope of 3. Or how about down 300, left 100, which is here. Okay, we're at 600. And we're going to go down 1 to 300. And we're at the X value 400. We go left 100. So we went down 300, left 100. Down 300 again would be 0. Left 100 would be 200. So now I'm here. So here is the line that it was traveling on. So let me just draw this. Whoops, I did not want an array. I want a segment. So we're going from here to here. And that would continue down until it got to the point 0, negative 600. Because we'd go down another 300, it would be negative 300 would be over to 100, negative 600 would be over to 0. So this is the path it's traveling. And when it gets to the point F, it hears the ping. And it turns and travels along a linear path given by the equation y equals negative 600, y minus 600 equals negative 1/3 times x minus 4. That is the point slope formula of an equation. If the homing beacon lies on the x-axis, which is somewhere down here, what is the exact location? Okay, so there's our visualization. So then we're going to be going somewhere this direction, and it's somewhere down on the x-axis. It could be here, it could be all the way over here somewhere. Is it a perpendicular? Does it say that? If the homing beacon lies on the x-axis, what is the exact location? Use your own graph paper to visualize this scenario. So it's somewhere on the x-axis way over here. Okay, so there's our visualization. So let's get that out of the way just for now. Okay, get rid of these dots. And it says, if point E is the y-intercept of the original equation, what is the coordinate of point E? Actually, instead of deleting all this, how about I just copy this over to a new page? Let's leave it just like that. Okay, so here we go. I've got it down lower here. If point E is the y-intercept of the original equation, what are the coordinates of point E? So the original equation is right here. If point E is the y-intercept of the original, what are the coordinates of E? Okay, well, it's right here. The coordinates of E are 0, negative 600. The y-intercept is 0, y. Okay, so then we're going to, this is just kind of giving us information that help us to figure out how to do this problem. So the questions are feeding our direction, if you will. So part B now says, what are the endpoints of the original segment motion? In other words, what is F? So the original segment, obviously we had the one endpoint E of 0, -600, but we also have the point F, and F is at the point or the location of 400, 600. Okay, and that was right here. So those are our two endpoints of the original segment that the robot traveled. Okay, so moving along, let's move this down to the next question and drag that up to there. If the beacon lies on the x-axis, what is the y value of point G? So they're saying if this beacon is on the x-axis, what is the y value of this point G? Okay, so if the y value, well, when we're on the x-axis, this is the point right here is 50, 0. This is the point 100, 0. This is the point 150, 0. So this question is saying, if the beacon lies on the x-axis, what is the y value of point G? And the y value of point G is 0 because it's an x-intercept. Fair enough. So now we know half of the solution to this. So now it says, translate point F to the origin. What are the coordinates of E prime, F prime, and G prime? So in order to get F to the origin, we're going to get an F prime. And it's going to be 0, 0. And in order to do that, we had to do a vector translation. So I had to move X. So my F coordinate was 400, 600. So if I go up here, it is this point right here, 400, 600. So to get 0, 0, I had to subtract 400 from my X, and I had to subtract 600 from my Y. So I'm going to do the same for F prime and G prime. So if F is 400, 600, E prime, or E was 0, -600. So I now have to take, so E prime is going to be the point where we take E, the original, and subtract 400, comma, where E was -600 and subtract the Y. Therefore, E is going to be the point -400, comma, -1200. Okay, and F prime is going to be the origin 0, 0, because it says translate the point F to the origin. So now F prime 0, 0. Well, what would G prime be? So G prime, here's the point G. The Y value is 0. So G is going to be something, comma, -600. And I don't know G. So we're just going to take G and subtract 400. So in terms of G, we're just going to say G prime is the point little g minus 400, whatever G was, minus 400, and then 0 minus 600. Okay? All righty, moving along. All right, so let's just clean this up because it's in my way now. Okay, so now E says use the formula derived in the lesson to determine the coordinates of point G. All right, so we know EF. Here's what we know. EF is perpendicular to FG. Okay, segment EF is perpendicular to segment FG. So I'm going to take my x values. So it's going, therefore, negative 400 times g minus 400 plus my y values, 1,200 negative times negative 600 has to equal 0. Ooh. Okay, so when I do this, I'm going to distribute, and I'm going to get negative 400g plus negative times negative is positive. 400 times 400 is 160,000. Is that right? Let's make sure I'm doing this right. I think that's correct, but let me make sure. 400 times 400, or 400 squared, is 160,000. Yes. Plus a negative times a negative is positive. 6 times 2 is 12. Carry the 1, 6, 7, and I have 4 zeros. Okay. Has to equal 0. Well, if I combine these, I get negative 400g plus 0, 0, 0, 0, 8, 8 has to equal 0. Okay, move that over to the other side and I get negative 400g has to equal a negative 880,000. To solve for g, I divide by negative 400, and that will give me g equals negative divided by a negative is positive. This 0 cancels that, this 0 cancels that. 4 goes into 8 2 times, 4 goes into 8 2 times, and there's still 2 zeros. So my g value x is going to equal 2,200. So we are way off. It'd be way over here at 2,200, 0. Okay, so that was pretty cool that we could do this using that new equation we learned in this lesson. All righty, I think Bernie's impressed. Okay, page 3 brings us to exercise 3. And it says a triangle in the coordinate plane has vertices at A, 0, 10, B, negative 8, 8, and C, negative 3, 5. Is it a right triangle? If so, at which vertex is the right angle? Hint, plot the points and draw the triangle on a coordinate plane to help you determine which vertex is the best candidate for right angle. So the point 0, 10 is right here. That is A. The point negative 8, 8 is B. And the point negative 3, 5 is C. So there is our coordinates. There are our coordinates for this triangle. So when I draw this triangle like so, then I look and I say, okay, the best candidate for the right angle is obviously angle C. That is closest to a right angle. B is definitely acute. A is definitely acute. So C is our best candidate. So this should be the right angle if it is a right angle. Okay, so how are we going to determine this? Well, I want to take and let's see. How can we do this? Okay, so if C is our best candidate, we want to move it to the origin. And C right now is negative 3, 5. So our translation will be right 3, down 5. Oops. Right 3, down 5. That will be the vector that will bring us from C to the origin. Okay, right 3, down 5. If I did that with every single vertex, then it would move the triangle down so that C's on the origin, and then we could determine if AC is perpendicular to BC. So we're going to do that without moving it. We're now just going to focus on our change. So in order to find the point B, so now how we need to move B down the same direction. So now my B prime is going to become the point -8 plus 3, which is -5, and 8 plus a -5 is 3. So that would move B to -5, moving it right 3, and down 5, we'll put it here at 3. Okay, so there's our B prime. We're going to do the same with C, and I'm sorry, A. We're going to move A down. So if A got moved to the right 3, so now I need to find an A prime. So my A prime is going to be the point 0 plus 3, 10 minus 5. Okay, so now I want to know if BC is perpendicular to AC. So I take the X values, -5 times 3, plus the Y values products of 3 times 5, and that has to equal 0. And I get -15 plus 15 equals 0. So therefore, obviously 0 equals 0. And yes, I can then say BC is definitely perpendicular to AC. Go back up. Is it a right triangle? Yes, because BC is perpendicular to AC, forming a right angle. If so, which vertex is the right angle? So the answer is yes, and its vertex C is the right angle. And we're done. Okay, so number 4 says we have a point A, -7, 1, and I'm just going to plot these just to have a reference as we're doing this. So A is -7, 1, which is here, A. B is -1, 3, right here. C is 5, -5. Oops, I didn't go down far enough. Okay, let's try this again. See if I get the correct domain and range. -7, 1 is A. -1, 3 is B. C is 5, -5, which is here. And D is -5, -5 here. So this was B, and this is D. So then if I connect these, here's AB, BC, CD, and DA. So there's the kite. So if I change colors now and draw a segment from D to B and A to C, they have to be perpendicular in order for this to be a kite by definition. That's what the question is saying. So I just wanted to show that to you. We want to determine if AC, so we know AC bisects BD, but BD does not bisect AC. Okay, so in other words, this side is congruent to that, but A to here is shorter than this. All right, so A, -7, 1, B, -1, 3, C, 5, -5, D, -5, -5. So this is saying our vertices of the quadrant of AC bisects BD. It does. But BD does not bisect AC. That is correct. Okay, determine whether this is a kite. So in other words, we need to determine if these two lines are perpendicular. That's what we're doing. So right now, our vertex, our point of intersection, I guess we should call it, is the point -3, -1. So in order to get that to the origin, I have to move it up, which is y. Let's go right first, x. I have to move to the right 3 and up 1. Okay, that would move this whole kite over to the intersection of AC and BD to the origin. So then I would have a vector from, let's use purple, from here, vector, purple, thinner, and there's our vector. We're moving this whole object right 3 up 1, which is what this vector set notation says. So when I do that, A is going to move. So let's just find all of these. So I'm going to say now, since that's true, A prime is going to be at the point -7 plus 3, comma, 1 plus 1. So A prime would end up -4, 2, which is right here. All right. B prime is going to end up at -1 plus 3, which is 2. 3 plus 1, which is 4. C prime is going to be 5 plus 3, which is 8. -5 plus 1, which is -4. And finally, D prime is going to end up at -5 plus 3, which is -2. And -5 plus 1, which is -4. So there are our new endpoints with this being at the origin. So I want to know if AC is perpendicular to BD. All right. So I'm going to use the endpoint A and I'm going to use the endpoint B. Those are the 2 points I'm going to use, the A prime and the B prime. So if this is true, then -4 times 2, my X values, products, plus my Y values, products, have to equal 0. And -8 plus 8 is definitely 0. 0 equals 0. So is it a kite? And the answer is yes, it is a kite because BD was bisected, but AC was not, and they are perpendicular. Page 4 brings us to the end of lesson 6. Go do your problem set and get some homemade mittens. Right, Bernie?